So this is our e-commerce customer churn analysis presentation. Gabby, Chris, Alicia, Krishma, and Alicia are all part of this. So for our agenda, this is what we will be going over. And then for context and questions. So the e-commerce industry faces intense competition where retaining customers is cheaper than acquiring new ones. So basically, customer churn occurs when the user stops purchasing or engaging with the platform. And the whole goal of this analysis was to figure out what key factors are linked to churn so the company can know where to focus to keep the customer with them for longer. So the main question we are going to focus on is which customer factors are associated with higher churn in an e-commerce platform.
So on the slide, I'm just going to go over some of our data and variables. Within our dataset, we had 5,630 customers with 20 variables spanning across demographics, behavior, satisfaction, and transactions. These variables basically help us figure out how the customers interact with the e-commerce site and which one of these variables can predict churn. And of course, our target variable is churn, with 1 equaling churned and 0 equaling active. Some of the main variables that we looked at were gender, tenure, satisfaction score, and customer complaints.
Okay, here we're looking at the basic patterns of the data before we run any models. So on the top left, you can see that the customers who churned had a much shorter average tenure, about 3 months, compared to the active customers who averaged around 12 months. So lower tenure clearly lines up with churn. In the bottom left, we can see that churn is also higher for customers with lower satisfaction scores. The very dissatisfied group churns the most, and the rate steadily drops as satisfaction increases. On the right, complaints show the strongest separation. Customers who submitted a complaint have a churn rate about 32% compared to around 11% for those with no complaints. All these visuals just tell the same story that low tenure, low satisfaction, and complaints all show strong relationships with churn. That's why we carry these variables forward into this regression model. The descriptive patterns give us a reason to test them
Okay,
further.
so for our method, we decided to choose logistic regression. This is just kind of setting the stage and kind of telling the story of why we did that. We thought it was best suited for binary classification problems such as predicting churn. So 1 equals churn, 0 equals active, meaning the customer is still interacting with the platform, and then churn, meaning that they've already left. It provides interpretable coefficients showing how each variable influences churn. So just kind of like how strong of an effect a coefficient has, and then whether or not a variable increases or decreases the likelihood of churn. It's simple, efficient, and effective for datasets with mixed numeric and categorical features. It was a really large dataset with a lot of variables, and a lot of them were numeric and a lot of them were categorical, so we just took that into account. Our overall goal is to interpret the data in an explanatory lens, not a predictive lens. So we utilized Python on Google Colab to clean, prep, and analyze the data results. It just gave us a really wide amount of metrics and just will give us a better analysis. With this, we were able to highlight coefficients, standard errors, z-scores, p-values, odd ratios, and confidence intervals. And this will just help us to understand which one of our churn variables is the strongest driver. And again, just give us a better analysis of the results. So we built this in Google Colab with Python, and this is also just how and why we made certain decisions. We did not split the data. We wanted to explain the data, not predict it. We just really didn't see the necessity of this. And then we examined class balance and found that the churn variable did not exhibit severe imbalance, so no resampling was required. There was no like crazy outliers or anything extreme in the data set, so we didn't do that. And then cleaning, pre-processing of the data, we imputed missing values. So this just means like taking out null values. There was a lot of like empty cells in our data set. It was 3.3% of the data set. So we took all those out and cleaned it just to prep it and then also prevent skew. We capped outliers using IQR-based winsorization. So just like the mean median, it helps to keep distribution and prevents like a small number of those extreme points from kind of taking over. And then one hot encoding categorical variables with reference categories dropped. One-hot encoding is like taking the categorical variables and turning them into ones and zeros just to be able to analyze it. And then we drop the reference categories to prevent multicollinearity and also to make the coefficients and p-values more interpretable.
To begin our analysis, we prepared the dataset entirely in Google Colab. First, we uploaded the file and removed all the extra unnamed columns generated when the dataset was saved from Excel. And these columns contained no information, so dropping them ensured that the dataset was clean and reduced noise. We then validated the churn variable, making sure it was binary and free of missing values. And after that, we addressed data quality by performing median imputation for all numeric variables. And to further control the influence of outliers, we used IQR-based winsorization on variables known to have extreme ranges, such as order amount hike from last year and cashback amount. And finally, we prepared the predictors by one-hot encoding all categorical variables and dropping the first reference category to prevent multicollinearity. And moving on to model fitting, once the dataset was prepared, we fit an explanatory logistic regression model using the stats models logit function. We selected stats model specifically because it provides the full set of inference statistics we needed for explanatory analysis, things like p-values, standard errors, and confidence intervals. And from the model, we retrieved several important metrics. The coefficients tell us whether each predictor increases or decreases the odds of churn. The standard errors measure how precise each estimate is, and the p-values tell us whether those relationships are statistically significant rather than due to random chance. And we also calculated odds ratios, which translate coefficients into a more intuitive measure of effect size. And finally, we generated 95% confidence intervals for the odds ratios to understand the uncertainty around each estimate and determine which effects are reliably positive or negative.
Clearly shows which customer traits relate most to churn. So first, 10 years protective, the odds ratio is 0.81, which means that every extra month on the platform reduces churn odds by about 19%. Next, complaint status is the strongest positive driver. The odds ratio is around 6, so customers who filed a complaint are about 6 times more likely to churn. Satisfaction score also matters. Its odds ratio is 1.34, showing that the lower satisfaction is tied to higher churn. Payment types also play a role too. E-wallet users have much higher churn odds, while credit card users have lower odds. Putting this all together, our highest risk groups are short tenure customers, people who filed complaints, customers with low satisfaction, users with multiple devices, and people using e-wallet payments.
This slide shows the regression table that supports those findings. You can see that the key predictors at the top, all the statistically meaningful p-values, and clear odd ratios.
So here I just want to go over some limitations. Our main limitation was despite having a detailed data set, we still lacked important data such as key behavioral and contextual factors that would have helped us look into the reasoning behind churn more. So this, for example, would be if a consumer has financial problems that would prevent them from being able to afford the products anymore. Some additional variables that would have helped us would have been detailed browser behavior. This would have been basically being able to see what the consumer clicked on the most, what they searched for the most, things like that, as well as competitor pricing and just seeing what similar e-commerce sites are offering that would cause consumers to churn and go to them instead. As for causal claims, since our data is observational, cross-sectional, and lacks time series data, this makes claiming causation difficult. Next, I just want to go through some recommendations. So one would be prioritizing customers that show behaviors with high churn risk. This would be focusing on the consumers with a high complaint rate or low satisfaction scores. Additionally, you can strengthen satisfaction scores with different initiatives such as product recommendations based off of what they've searched for, loyalty programs, and discounts and coupons to increase engagement. Finally, you should invest in correcting operational or experience related pain points. For example, this would be if there are any shipping delays that could increase complaints, or maybe if the website itself is lagging and not working very well.